Hello everyone. In example number 5, we have a man walking along the path. So here's the man and he's walking along the path. There's a searchlight right below the path, which is 20 feet from point P on the path. So this is 20 feet from point P on the path. So the searchlight is projecting on the man. At point P, we have a right angle, and that gives us a right triangle. So we want to know at what rate is the searchlight rotating when the man is 15 feet from point P on the path closest to the searchlight. Let x be the distance on the path and theta be the angle in between. So we want to find out what is d theta dt. D theta dt is the rate of the searchlight rotating when x is 15 feet away from point P. This is what we want. To find d theta dt, we need to relate the picture using trigonometry. We have x is opposite and 20 is adjacent to theta. X is opposite of theta and 20 is adjacent next to theta. We are going to use tangent. So the formula that we have based on the picture is tangent theta equals x opposite over adjacent, which is 20. We also know from the given information that the speed along the path as the man walks along the straight path is dx dt equals 4 feet per second. We're going to need to use that later. So here's our given, and let's go to the right to show our work. We are going to start with the formula, the equation describing the picture, which is tangent theta equals x over 20. 20 tangent of theta equals x. Now we need to differentiate both sides with respect to time because we want the rate with respect to time. So we take d dt both sides. So here, d dt. The derivative of 20 tangent theta with respect to time is 20 secant square theta times d theta dt. The derivative of x is 1 times dx dt. Now we're going to divide both sides by 20 secant square. So 1 over 20 secant square theta dx times dx dt. And we know 1 over secant square is cosine square. Bring that to the top over 20 times dx dt. And that is d theta dt, the rate of the searchlight rotating. In order to get the final answer, d theta dt, we need to find out what cosine of theta is. So using the right triangle, we have base, the height, and the hypotenuse. Given x equals to 15, we need to find the hypotenuse because cosine of theta is adjacent over the hypotenuse. So we have 20 square using the Pythagorean theorem plus 15 square equals c square. So c equals the square root of 20 square plus 15 square. C equals 25. So cosine of theta equals adjacent, which is 20, next to the angle theta, over the hypotenuse, which is 25. So let's write it here. Cosine theta equals 20 over 25, which is 4 over 5. Now we can do the final substitution to find d theta dt. d theta dt equals 4 over 5 square divided by 20, or time 1 over 20, times dx dt. And we're given dx dt is 4 feet per second. So let's write that down. That is 4. We can cancel the 4 with 20, so 5 as the denominator. And 4 squared is 16, divided by 5 squared is 25, times 5. d theta dt is 16 over 125 radians per second. And that is the rate, how fast the searchlight is rotating. Good luck on your homework, and I will see you in the next video.